Hello everybody and welcome to the third video in a series of tutorials on test automation utilizing AWS SQS. Last video we were able to start the server and were able to send the HTTP messages to the server and the server push those messages to SQS, and today we're actually going to start looking into automation code. And the first thing you need to do, you need to go to this repository, GitHub repository, where I have stored that automation code, and we need to clone it. So go to code, go to click on this copy item, and then open your terminal. I'm gonna clone it to the desktop, so I need to navigate to my desktop, and then I'll type git clone, and then the URL. It will clone this repository. As you can see, I have the regular repository where the server resides, and I have another one with the test automation. Okay, we can close this terminal. So the next thing, then open the AWS SQS test automation framework folder. Click open. That will open the project that we just downloaded. It's gonna take a second, so I'm just gonna pause the video. After the project is opened, so we need to click on the terminal, and we're going to run mv and install to install all the packages that we have inside of this project. And I'm gonna go over those packages just in a second. So just type mv and install, and it's gonna take a second, so maybe up to a minute. If we go to SQS client, the class that actually implements ISQS customer, and you can see we have the constructor here that accepts the region, and then it builds the SQS client instance of the SQS client. So this is SQS client is part of the AWS SQS, which we imported. It's not something we develop. Then we have the send message, get message, and delete message all being implemented using this SQS client. This method, send message, is part of the SQS client object, and we're passing the send message request, receive message request, and delete message request accordingly. And we also return appropriate objects from these methods. The next important class that we're going to look at is HTTP client. So this is actually the class that send the HTTP messages. We have only two methods, the post and get. And in the constructor, we create an instance of HTTP client, and this is part of the, if we expand import, this is the part of the java.net. This is the native Java libraries that we're using here, and we also have the send method, which will send the request of this type of HTTP request object, and also the how we want to handle the body. We want to handle that as a string, and identical situation with the get method. First interface, we're gonna look at iCustomer service HTTP. So pretty much this is the interface that deals with sending customer information via HTTP request. So you can see that get customer, we get the ID, and then add customer, we provide the customer, we return HTTP response in both of those situations. Implement this interface is located at testlogic.services. Honestly, don't like that naming, but let it just be. Customer service HTTP. So you see it's implement this method, and again, get customer, add customer. We implement those methods in here. Next interface will be iCustomer Service SQS. So this is identical. This is close to what HTTP has, but it actually deals with sending message directly, sending customer information directly to the SQS queue instead of using the HTTP. And the class that implements this interface is Customer Service SQS. So you can see we have the send customer method and find method. They send customer accepts the customer to send, and find is accept the ID. And as you see here, we're using the dependency injection. I'm gonna go over that a little bit later, but pretty much we inject the ISQS customer interface into this class, and we perform the calling the methods add and find respectively. Let's go to HTTP customer. This interface has two methods, add customer and find customer. It's also done through the HTTP. So pretty much distinguishing between performing certain action between HTTP and directly invoking SQS. This interface is used in the API HTTP customer repository. As you can see, we implement this interface with add and find methods where we perform the logic of actually um, building the HTTP request and then sending. So here we're sending the post request, posting the customer, and here we find it's a get request to find the customer. As you remember in the last video, we used the postman to do that, so we need to mimic that situation. These methods, that's what they do. They pretty much just send the information to this URL instead of us doing it manually through the postman. We're just gonna send it directly and then do the assertions. HTTP customer repository, so pretty much HTTP purchase repository. So this is pretty much for creating a purchase. This is the response decorator. So this is the helper class that help us work with the response. They just get the body based on the object that we are expecting. And next, look at the model. So we have customer to receive model. Let's start with customer to send. So we have customer to send model. Instead of building getters and setter, we're using the Lombok projects. It's just easier than typing getters and setters. I know some of you will say, hey, there is the shortcut in the IntelliJ that will generate automatically. I agree, but I personally prefer this way. Customer that will receive close to what customer to send object is, but has the ID since we assign the ID to the customer. Lead is the information where we return the customer with the purchase history. That's why we have a list of purchase histories over here. Product is the part of the purchase history object, which is has the name and the price. And purchase history just the class that contains two properties, list of products and the email of the customer, because we need to do the linkage, right? So we need the email for the purchase history. And we already looked at the customer repository, so we have also HTTP purchase repository class where we create new purchase. Again, instead of doing that through the postman, this method will send the post request to create the purchase history. We look at the clients. SQS customer repository. So this is actually the class. This is a very important class because this is the class that's actually working with the SQS. And we have the couple methods here. We have two add methods. We're using the method overload here. This method accept customer and attribute, and this method just accept customer, and then we're using the send message on the SQS client class that we extend. And we have a find method that accepts the ID. And what we do, we return get all the messages, and then we use the find method, which is private. We do not want to expose this method outside of this class. And this method pretty much just iterate over the array and find the customer that matches the ID. We also have the delete message where we accept the message, and um, we're calling the delete message on the class, the SQS client class that we extend. Test data is the folder where we have our test data. So you see John Doe and then purchase. This is our purchases. We have our test logic services. This is the couple of classes that allow us to work with HTTP and SQS. As you see, we're injecting the HTTP customer, invoking the methods that we need, and our test scripts will be calling these methods directly. Additionally, we have helpers. Convert class is a helper class that convert object to string and string to object. Data time helper, also a class that help us to do the data conversion. The IOC class, it's the class that helps us to deal with the dependency injection. So as you can see here, we are pretty much binding the interfaces to the concrete implementation, and we'll be using local data repository is a class that allow us to get the data um, from the test data JSON files and convert them into respective objects. So as we see, customer to send will utilize this customer to send object, and purchase history object to convert JSON into the classes. This is also a helper class to read from those locations that we just discussed. And then SQS message attribute builder. This is pretty much the class that build the SQS attribute. If we want to send the attribute beside the message, we can send the attribute that we can use for different purposes. And the most important, obviously, is tests. We have the only single class customer test. As you can see, we are pretty much using the GUI's dependency injection, and we are saying, hey, use this class, the ISC, which stands for inversion of control, as a dependency injection, and we inject these interfaces into our. As you can see, we never actually create an instance of our classes that we will be using. For example, as you can see, customer service API, we're using it on a line 44, invoking the add method. However, we never create an instance. This is done by our ISC class. So I will pretty much inject that interface, and we're saying, hey, look at the ISC class for the binding. So what happens is so we come to IOC class, and we see that iCustomer service HTTP binds to customer service HTTP concrete implementation. So our test case knows, hey, whenever we inject, our test case knows whenever we inject iCustomer service HTTP, we need to use the customer service HTTP um, class for that. And customer service HTTP class has the add method. That's the method that will be invoked over here. In general, dependency injection and inversion of control, it's a big topic. I'm not. As you can see, we have three test cases. The first one should post message in SQS when your customer created, and And what we do here, we're sending the message through the HTTP, and then we're reading from SQS. We're finding the customer based on ID, and then we ascertain that the customer that was sent matches the customer that's now in SQS queue. Second scenario, should convert name to uppercase when new customer created. This is the use case that I was telling you about in a previous video, where we send the first and last name with the lowercase, but we're expecting that to be stored in SQS with the uppercase. Again, super simplified business rule. In the real world, that will be way more complex business rules and business needs. Pretty close steps. So we send the message through HTTP, and we read it from SQS, and we're making sure that the first and last name are uppercase, and the last name is the last test case. And the last test case is should link purchase history to new email. This is the business case where if the customer create a new account, and the new account with that email already made some purchases, we want to do the linkage so we know who made those purchases, and we can pretty much, the idea is to personally target that customer. And the last name is should link purchase history to new email. So pretty much business use cases. If the customer already had the purchases before, we store their email. If customer create a new account using that email, we wanna make a linkage between their previous purchases and the new account. So it appears to us, instead of some random person with their certain email made purchases, um, person with particular first last name date of birth made those purchases. And what we're going to do, we're going to create new purchases. We're reading from that local data repository the JSON file for the purchases. This one purchase, the JSON file. The HTTP request with that purchase history, which ideally will be stored somewhere in database. For our purposes, it's going to just be stored while the server is running. And then we make a call, and then we actually using the HTTP again to create a new customer, and HTTP request to create a new customer, which will return us a customer with that purchase history. I call it lead. And then we pretty much asserting that purchase history is not null. And in the next video, we actually gonna put a breakpoint and go step by step, and I will walk you through how everything works all together. I'll see you next video.